All right, start off on number 1 here. So for this one, they want us to simplify our answer, which kind of just means get rid of the parentheses. So I would just distribute the everything in front of the parentheses first. So that's going to look like that. And then this one will be t to the third minus t squared. And then this one we do have to distribute that negative, so negative t to the fourth and then plus 2. So then next up, I would just combine like terms and then get your final answer. So you're usually going to want that in the power order, so do the biggest power first. All right, next two here is the a binomial squared. So for these ones, because there's adding or subtracting in there, we're not allowed to just send the squared in there. We have to write it twice. Then we have to FOIL it. So I got 36, and then I have negative 54y, and then negative 54y, and then positive 81y squared. And then as I combine like terms, I would go ahead and put this again in standard form. So I'm going to put the power, 81y squared first, and then I'll combine these to get my negative 108y. Oh, that's not squared. And then plus 36. So that'll be my final answer there. All right, next up here just wants us to distribute this, and so we're going to add the exponents there. So that's going to become the 4 over 4 power. So that would just be the first power. And then this one I would add the exponents 1 over 4. 1 over 4 would be 1/2. And I would just leave my answer like that. Remember, now we would only combine these if they were like terms, which obviously they're not like terms since they have different exponents. I guess if you wanted to write it like this, that would work as well. I think it would take both of those answers. All right, next up here, again, they want us to simplify. Now, these are conjugates, so we can go ahead and fill here. So first times first, well, since those bases are multiplying, we're actually adding the exponents, so it's going to be 18 over 2. And then same thing for the y, is going to be 18 over 2. So I would just write that as x to the 9th minus y to the 9th. There you go. All right, next up here, number 6. These are actually, again, conjugates. You'll notice if you kind of just think of this all as one thing, then it's the same thing but 1 plus and 1 minus. So I'll go ahead and and if I multiply a radical by itself, the radical just goes away. So that's actually not too bad. And then I do last times last, and that'll just be minus 1. So actually all of that's just going to leave me with h squared. All right, here it says factor out the common factor. So now our goal is to factor. This one is where I start using the u substitution. So I'm going to let u equal whatever is in the parentheses. So that'll be z plus 9. And then so we can write this as u squared minus 10u. And then so that we can clearly see that with GCF a u there, that's the common factor they were talking about. And that'll leave me with u minus 10. And so now I'm going to reinsert u back in. So this one will be z plus 9 out front. And this one will be z plus 9 minus 10. And I'll just kind of combine like terms on that second parentheses there. So it'll just give me z minus 1. All right, next up here we got some factoring. Looks like there's no GCF, so I'll just do my diamond here. So we'll do a times c up top, and that'll be, let's see, make it 30, and that'll be negative 90 and 13. So 90, what multiplies to make 90? Well, I know it's 2 and 45. I got 3 and 30. Is 90 divided by 4? No, it doesn't. 90 divided by 5. Well, 10 would be 18. There we go. So I'll do it as a positive 18 and a negative 5. However, since we have our a value here, we're going to have to go ahead and rewrite this, but we're going to split up that middle term as negative 5x and positive 18x. And then we'll group it together. And the first group looks like I could just take out an x. Second group, I can take out a 3. And so I got me x plus 3 for the outside, and then 6x minus 5 for the inside. All right, the next two here are pretty similar, so I'm going to go ahead and do number 11. So for both of these, I would use u substitution. So you're going to let u equal whatever's in the parentheses, so I'm going to do a plus b here. So I'm going to write this as 5u squared plus 9u minus 2. And now I'm going to do a diamond factoring. So I got negative 10 up top for the a times c, and then 9 on bottom. So that'll be 10 and negative 1. And since I have an a value here, I have to now do the grouping. So I'm going to split this up as 10u and negative 1u from over here. And now we'll do the grouping. So the first group looks like I can take out 5u, and that'll leave me with u plus 2. Second group doesn't look like I can take out anything, but I'll have to take out either a 1 or a negative 1. In this case, I'll take out a negative 1, which will leave me with u plus 2 as well. So I get 5u minus 1 and u plus 2. All right, so now I need to reinsert the u back in from the kind of start here. So the only kind of trick here is because this 5 is multiplying by u, I have to plug it in brackets. So I'm going to do bracket a plus b minus 1. On this one, that's not important because there's nothing multiplying in front of u, so I'm not going to worry about it. So this one still requires some simplification. So I'll go ahead and distribute that and write my final answer here as 5a plus 5b minus 1 times a plus b plus 2. Oops, a plus b plus 2. So there you go. There's no like terms to combine, so I'm just going to leave it like that. All right, next up, number 13. So again, here I would use some u substitution. I would let u equal x plus 9. And so I would call this u squared minus 4. And then it's pretty clear to see we'd do a difference of perfect squares factoring here. Oops, it's going to be a 2. All right, and then I would plug it back in. Now, since nothing's multiplying by u, I don't have to worry about distributing. So I can just go like this, and then x plus 9 plus 2. And we'll go ahead and combine like terms here. So we got plus 7 and then plus 11. All right, 14 is a perfect cubes here, but I'm going to do the next one. I'm going to do number 15. All right, so next up, here we're going to use our perfect cubes like I said. So you're going to do one small parenthesis and one big parenthesis. So this is really 1 to the third plus 512 is 8 to the third, and then y to the third. So this is going to be 1 and then 8y here. And over here I got 1 times 1 is 1, 1 times 8y is 8y, 8y times 8y is 64y squared. And then we're going to do our SOAP here. So since this one was a plus, we're going to do same, opposite, always positive. I think that should work. If it doesn't, I might try it in the standard form. So kind of put it the other way around. Just be careful about your pluses and minuses. Just rearrange it to have the biggest powers first. And so try that if the first one doesn't work. If I was grading this, I would take either one. All right, next up, we want to factor this completely. Now, in this case, we're going to start off with a common factor. So I always take out the smallest power of x, so it's going to be 1/2 here. And then to get what's left inside, I always do kind of the exponent I had minus the exponent I took out. So it's going to be 4 over 2 here, which will be 2, so it'll be x squared. And then this one will be minus 64. No x there since I took out that whole half power. All right, so then next up, I see that I can break this down some more. So I'm going to break down as the difference of perfect squares, x plus 8, x minus 8. I think that should be good. If it doesn't work, you could write this as rad x times x plus 8 times x minus 8. Obviously, the 1/2 power means the same as the square root. All right, next up here, we kind of have the same idea as last time. I want to take out the smallest power of x, and in this case, the smallest power is actually the negative 1/2, since it's negative, of course. And so if I do that, I'm going to be left with 10 to start with. That first one, I took out the whole power, so it's gone. The second one here, I have 7x, and then that is going to be the power I had minus the power I took out. And so 1/2, and that's actually plus 1/2, and that's going to be 2 over 2, or 1. And so that's my next power. And then I'll do plus x here to the power of, and I got 3 over 2, what I had minus what I took out. So again, that's going to be adding, so it'll be 4 over 2, or 2. All right, I think that inside's probably going to be factorable again. So I'm going to rearrange it in kind of the more normal form. Keep that guy out front. And then we'll factor this. So we got 10 and 7, so it's 5 and 2. All right, and since we don't have an a value here, we can just call that x plus 5 times x plus 2 from these numbers right there. And that might be okay. If that doesn't work, you could always write this as x plus 5 times x plus 2. And since that is multiplying, we can drop down to the bottom like that. So you could try it like that. You could also try it, I don't know, as 1 over x to the 1/2 times like this. It really means the same thing, so try a couple things out there. I feel like this one should probably work, but if not, try that one as well. I like that one. All right, same idea on this one. I'm going to factor out the smallest power of x, and in this case, since they're all negative, the biggest negative is actually the smallest number, so that's what I'm going to take out front. So that's going to turn this first term into a 1. And then this term, I'm going to have a new power of x. I'm going to take the power I had minus the power I took out. Once again, this is going to end up being addition here, so that'll be 2 over 2, so that'll be the first power. And then plus x to the power of, and then I have negative 3 over 2. I had it, and then I took out a negative 7 over 2, so that leaves me with 4 over 2, which is squared. Once again, I would rearrange this like this, and then factor it. So multiplying to 1 and adding to 2 would be 1 and 1. So I would always write that as x plus 1 squared here, since it came up twice. And then I would go ahead and drop this x to the 7 over 2 down to the bottom. You may have to write it like this, so if that first way doesn't work, just kind of like last time, go ahead and write it like that. All right, now we're going to kind of combine the last two ideas. So we're going to combine the fractional exponents with the u substitution. So I'm going to let u equal x minus 6 here, since that's in the parentheses. So this will become u to the 7 over 2 minus 36 u to the 3 over 2. So I can go ahead and factor out here u to the power of 3 over 2. That's the smaller exponent. This will become u to the 4 over 2, since I subtract those. And so that'll just be squared minus 36. And I see I can actually factor that some more, so it'll be u minus 6 and u plus 6. And now I'm going to reinsert my u back in, so that becomes x minus 6 to the 3 over 2 here. This becomes x minus 6 minus 6, and this becomes x minus 6 plus 6. So now I'll combine like terms, and I'll write, I think this will be my final answer here. It'll be x minus 6 to the 3 over 2 power times x times, actually, that'll be x minus 12 first for this one, and then that last one will actually just simplify to x. Let me see how they put the answer here. Yeah, they actually put that out back, so you can actually, I think you can put it like this. That should be fine. If that doesn't work, oh, you know what? They don't have the x in parentheses here, so you might want to write it like this with just the x. All right, some kind of more of the same here. So I'm going to use some u substitution, let u equal x squared plus 7, and then we will call this u to the 1/2 plus 9u to the negative 1/2. And so I'm going to factor out u to the negative 1/2 power, since that's the smaller one, and that'll increase this one to a power of 1, and that'll just eliminate that u. No more factoring I see I can do, so I'm just going to call this x squared plus 7 to the negative 1/2. And then we're going to call this x squared plus 7 plus 9. I would definitely combine like terms on the this parentheses, so it'd be x squared plus 16. And I would probably drop this down to the bottom and make it x squared plus 7 to the positive 1/2 now. All right, here we got some trinomial factoring. So I would just use my diamond for this. So a times c would be 81 here. Because we always just kind of do the numbers in front. I know there's a y squared back there, which makes it look trickier, but really it's just a 1y squared. And I got 18 in the middle, so that's going to be 9 and 9. So since I have kind of a weird a value here, I'm going to rewrite this, but I'm going to split up that one in the middle as 9xy and 9xy, and then plus y squared. And so now I'm going to use my grouping. And the reason I attached the xy here is because that was that middle term. And so I'm going to take out a 9x out of the first one, which leaves me 9x plus y. And then I can take out a y out of the second one, which leaves me with 9x plus y. And so this would just be 9x plus y times 9x plus y, which I would guess they want you to write as 9x plus y squared. All right, got some more u substitution here, so I'm going to let u equal x squared minus 49, and so we got x squared u minus 4u. So all I see you can do is factor out a u so far, and then I could factor this as the difference of perfect squares. And now I will plug the u back in, but then I see I can break that down, So I'll do x plus 7, x minus 7, x plus 2, x minus 2. Number 23 here, this is a trinomial, so we would use the diamond, but before we do, we have to GCF an x first, so make sure you do that. So it'd be x squared plus 4x plus 4 once you GCF that x out front. Then I would do the diamond. I'll let you guys do that. All right, here we're just going to jump into our factor by grouping. So I'm going to group these two together, and I'm going to group those two together. And so the first group looks like I can take out 4x squared, which leaves me with x plus 3. The second group, I have to take out something, so I'm going to take out a negative 1, which would switch this to x plus 3, so it matches up. So now I can write this as 4x squared minus 1 times x plus 3. And I could break this one down further as 2x plus 1, 2x minus 1, and x plus 3. All right, next up here, we kind of have two weird things in the parentheses. So what I would do on this one is that I would label them as two different variables. So I'm going to make this u equal x minus 3. And I'll just go ahead and use k here for the other one. It really doesn't matter. I'm just kind of making up another variable. And so this will be u times k squared minus u squared times k. So then I would do a GCF here. So it looks like what I can GCF is a u and a k. And that would leave me inside here with k minus u. So now I don't see any more factoring I can do, so I'm going to reinsert here. So I got x minus 3 for u, x plus 7 for k, and then the next k here is going to be x plus 7 minus, and then this is kind of the really tricky part is we have minus u right here, so I got to do a bracket for my x minus 3 in there. Because I got to distribute this negative, so that's going to be negative x plus 3, which then if I combine like terms, the x's actually cancel out, and I'm left with 10 here, times x plus 7, x minus 3. That is done. I usually like my 10, if I have like a constant like this, I like to move it out front, like so. All right, next up here, number 26. So for this one, I would use a u substitution again. I would let it equal y plus 12. That's the weird thing in the parentheses. So we have 36y to the 4th, and then times u to the 3rd, plus y to the 5th, and u to the 4th. So it looks like what I can take out here is y to the 4th, that's the smallest power of y, and u to the 3rd is the smallest power of u. So that's going to leave me with 36 plus y times u over here, since I didn't take out all of either of those. And so now I can reinsert the u back in. And so I'm going to go ahead and do that. So it's going to be y to the 4th times y plus 12 to the 3rd times 36 plus y, and I'll go ahead and do a bracket here since I'm reinserting and it has something multiplying, y plus 12. And so I need to distribute into there, so it's going to be y squared plus 12y. There's no like terms, but I'm going to go ahead and rearrange this as y squared plus 12y plus 36. And then I noticed that that's a factorable trinomial here, so I'm going to think of two numbers that multiply to 36 and add to 12, so that would be 6 and 6. And so I'm going to write my final answer up here as y to the 4th times y plus 12 to the 3rd times y plus 6 squared, since I got the same number twice. All right, next question here. We've got a lot going on, and so looks like I kind of have two weird things in the parentheses here. So I'm going to let u equal x squared plus 2. And I'll go ahead and use k again, and I'll do that for x minus 2. So now I got to rewrite this as 5 times u to the 4th times 2x times k to the 4th, and then plus u to the 5th times 4 times k to the 3rd. Okay, the next thing I would do is, since these are kind of together, I would multiply these and give me 10x times u to the 4th, k to the 4th. And then this 4, I would move that to the front of this term back here. And now we got u to the 5th and k to the 3rd. All right, so now we're going to GCF here. So I'm going to take out a 2. It looks like I cannot take out an x. I can take out u to the 4th. I can take out k to the 3rd. And that's going to leave me with 5x, k, plus 2u, and no k on that one. I took them all out. Okay, so just double check here. what did we do? So this one had we took out all 4 powers, so no more u. We took out 3 of these k's, so 1 k left. This one we only took out 4 of the u's, so we have 1 left, and we took out all the k's. All right, that looks good. Now we're going to reinsert everything back in. So we're going to call this x squared plus 2 to the 4th. And then this one will be x minus 2 to the 3rd. This one will be 5x, and then we'll do a bracket here for k as x minus 2. And then this one will be plus 2, and then we'll do another bracket for x squared plus 2 as we reinsert this stuff back in. Okay, next up is I got some more work over here. I have to distribute this 5x into there. It's going to be 5x squared minus 10x. Got to distribute that 2 in there, so it'll be 2x squared plus 4. Combine like terms there, so we get a 7x squared minus 10x plus 4. I'll go ahead and rewrite these guys over here, but kind of been ignoring them. It's okay as long as we put them back later. Last thing I would do on this trinomial over here is I would try a diamond multiplying to 28 and negative 10. It actually doesn't work in this case, and so I am done. But I would say we did enough work on that problem, wouldn't you? All right, next up here, kind of same idea. So I'm going to use 2 variables. I'm going to let u equal 4x minus 1. I'll let k equal x plus 1. And so I'll go ahead and rewrite this. I'm going to go ahead and multiply the 3 and the 4 here and call that 12. And then we'll go u squared k to the 1/2. And then I'm going to say plus 1/2. I'm going to move that to the front, and then I'll call it u to the 3rd k to the negative 1/2. All right, so then next up, I'm going to start with my GCF. I'm going to take out u squared. I'm going to take out k to the negative 1/2, since that's the smaller exponent. So this will leave me with 12. The u is gone, but now my k is to the first power, because that's the 1/2 minus a negative 1/2 there would give me the whole k. And then over here, I'm going to have 1/2, and we're going to be left with a u, but no k. All right, so now I'm going to re-plug back in. So u is going to be 4x minus 1 squared. This will be x plus 1 to the negative 1/2. And then this will be 12 bracket x plus 1 plus 1/2 bracket 4x minus 1. All right, so we need to simplify over here. So I'm going to call this 12x plus 12 plus 2x minus 1/2. And then we'll combine like terms, so it's going to be 14x. And then I'll do 24 over 2 minus 1/2. And so that'll be plus 23 over 2. And then I think you can just leave these alone. Let me check the answer key, and that looks like it's correct as long as we have all of these here. Looks like even with that negative exponent is still good. If you want to drop that down to the bottom, that would certainly be okay. All right, next up here, number 30. So it looks like I only need one u here. I'll make it x squared plus 4. So this is going to be u to the negative 1/5 minus 2 over 5 x squared times u to the negative 6 over 5. So it looks like the only thing I can factor out front is u to the negative 6 over 5. That's the smallest exponent. And so that'll be left with a u, and I had a negative 1/5, and I took out a negative 6 over 5, so that's going to leave me with a 5 over 5. So that'll just be a first power of u. And then this one will be minus 2/5 x squared. No u there, since I took out the whole power there. Okay, so now I'll reinsert. So now I have x squared plus 4 to the power of negative 6 over 5. And then over here I have x squared plus 4 minus 2 over 5x squared. So I'm going to kind of combine like terms here. I'm going to think this is 5 over 5. So then I can call this 3 over 5x squared plus 4 times x squared plus 4 to the power of negative 6 over 5. So I just leave it like that. All right, last one here we'll do is we'll set up a u equals 9x plus 8. So I'll write this as 1/2 x to the negative 1/2 u to the 1/2 minus 9 over 2 x to the 1/2 and u to the negative 1/2. So it looks like what I can factor out here is, you know what, I can factor out a 1/2 here, which I'd really like to do. and I'll show you what we want to do with that. Looks like the smallest power of each of the variables is -1/2, so I'll take that out in front. So I think it's kind of obvious here that taking out that 1/2 is going to turn this into a 1, because I kind of took that out front. So I'm not even going to write that one, actually. I'll scribble it out here. The x to the -1/2 I took out, and then this will increase the u to the power of 1. And then on this one, I'm going to call this a 9 right here. And if you kind of think about if we distributed that 1/2 back in, that would give us that 9/2. And then I took out a -1/2 here, so that's going to increase that one to just an x to the first power, and then no u on that one. So I'm going to reinsert back in, so I get 1/2 times x to the -1/2 times u to the negative. Actually, I'm reinserting here, so I'm going to call this 9x plus 8 to the -1/2. And then inside of here, I have 9x plus 8, and then minus 9x. I don't need to distribute anything that u, so I don't need a bracket. And I notice here these cancel out, so I'm actually left with an 8 back there. And so the next thing I would do, since that's just an 8, I would multiply it with the 1/2 and call that 4 times x to the -1/2 times 9x plus 8 to the -1/2.